Hearing loss is the most common sensory deficit across the globe. By 2025, 900 million people will be affected by hearing loss. It's also been associated with increased social isolation and depression, and that leads to huge costs personally and for society at large. The problem that we have to overcome is we cannot see inside the inner ear, and so for the vast majority of people, we don't know why they're going deaf. And the Bertarelli Program for Translational Neuroscience and Neuroengineering has enabled us to actually tackle this difficult problem. How is your hearing now?
My hearing aid in my right ear, which is turned all the way up, and I can barely hear you. And if I don't have my hearing aids in, I can't hear myself talk. Even with the hearing aids in, I can't hear myself breathe. And you're in isolation.
Because you had a brain MRI scan and everything looked okay.
Yes.
So this is a big enigma.
I've been totally healthy my whole life. This just blows me out of the water. So it's very frustrating.
Patients like Sally are really frustrated by not knowing what is causing their hearing loss. They keep asking, why, how can that be? We're in the 21st century, technology is exploding, and you still can't tell me what's wrong with my ear? Well, how can you then help me? And they're right. The incredible vision of the Bertarelli Foundation allowed people with complementary expertise to come together and talk about big and important problems in neuroscience and see if by joining forces and thinking out of the box, we may be able to solve them. Dimitri Psaltis, he is an optical engineer and has been studying how to view things through turbid media. And I realized if he really knows how to see through difficult encasing bone, then we could look inside the inner ear.
Well, that was actually Tina coming to me at an event organized to get the Harvard and the EPFL people together. And she said, well, we have this problem that we cannot see inside the cochlea. Cochlea is a very, very small organ, converts the sound into electrical signals. And she said, well, we'd like to be able to see what the problem is.
A majority of hearing loss originates from the inner ear. And the inner ear, so it's one of the few organs in the body that you actually cannot biopsy.
The hair cells that are located inside the cochlea here basically are directly connected to our brain. We have encasing bone around, so it's really difficult for the tools to access. So the first thing is, how do I get there?
The first stage of funding was to find out whether there is a way to see the cells. We looked at cochleas that have been extracted from mice. And the major finding then was that you could see under normal microscope fluorescence. Which means that in human we could do the same thing.
And when we saw that we could see individual cells, we thought, wow, let's keep working on it.
The next step was to do this in humans. And for that you have to enter the ear canal through the middle ear and then get to the cochlea, and you have to design an instrument and look inside.
This setup that you see here is a prototype version of what we call a confocal microscope. So it is, in a sense, a regular microscope, except that it allows you to see things in 3 dimensions.
And then through that you could see about half of the first turn of the cochlea, which is the part of the cochlea that's responsible for high-pitched noise, which is the part that gets damaged the most.
Of course, seeing these cells for the first time has been exhilarating.
The next step is to make a version that Tina can use in humans. So we need to have something that is engineered to be handheld.
What that would mean is that we could actually tell what's wrong in patients' inner ear. We can then design and customize therapies for a given patient.
It affects me socially. It's got to be frustrating for whoever I'm speaking with, too. My husband says, I miss talking to you.
We are incredibly grateful to the Bertarelli Program for allowing us to tackle what seemed as an impossible task.
If we're successful, we can help the people here.
Right now my world seems like with each day it gets smaller and smaller. I hope it's within my lifespan, that they're going to come up with some answers and some equipment that will bring you back to life.